Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0963, indicates a high-voltage condition in the CVT drive pulley pressure control valve circuit for the Honda CRV models from 2017 to 2022. This is an electrical issue rather than a mechanical fault within the transmission system. The Continuous Variable Transmission, CVT, is responsible for smooth transmission of power without distinct gear shifts. The affected component is the CVT drive pulley pressure control solenoid valve, located within the transmission assembly. This valve regulates hydraulic pressure to the CVT drive pulley, contributing to optimal performance and fuel efficiency. A high voltage in this circuit generally points to an electrical problem, which must be investigated and resolved before assuming direct mechanical issues. Understanding the proper functioning and location of these components is crucial to effectively troubleshooting this DTC. The CVT drive pulley pressure control valve is essential for managing the hydraulic pressure within the Continuous Variable Transmission, CVT system. This valve is pivotal in achieving smooth acceleration and maintaining engine efficiency. As part of the transmission assembly, it is not easily accessible, hence requires a degree of expertise to test and replace. The error code P0963 signifies an abnormal high voltage detected in the circuit controlling this valve. Importantly, this issue is related solely to the electrical circuit and not to any mechanical issues potentially affecting transmission performance. The DTC includes the confirmed status and can be either active or pending based on conditions during the vehicle's operation. Recognizing the location and function of the valve assists in directed and effective troubleshooting. The potential causes of DTC P0963 mainly revolve around electrical circuit issues. One significant concern includes short circuits that may lead to high voltage readings in the valve circuit. Such shorts typically arise when wiring insulation is damaged, causing wires to touch unintended power sources. Additionally, open wires in the circuit can interrupt normal signal flow, which can also lead to the observed high voltage. Poor ground connections are another notable cause. These can create erratic electrical behavior in the solenoid valve's operation. Each of these components must be checked to determine the specific fault causing the DTC, ensuring a thorough troubleshooting process is followed. The symptoms associated with DTC P0963 may vary based on the severity of the fault. One common indication is noticeable transmission performance issues, which could manifest as hesitation during acceleration or unusual shifting behavior. Drivers may also observe that the vehicle cannot accelerate smoothly as the transmission struggles to adapt to power demands. Additionally, the check engine light is likely to illuminate, alerting the driver to the electrical malfunction. The irregular acceleration behaviors could lead to an overall poor driving experience, potentially affecting safety. It is crucial for drivers to observe these symptoms and seek diagnostics promptly to avoid further damage to the transmission system. The first step in troubleshooting DTC P0963 entails verifying the issue effectively. Start by turning the vehicle to the on mode without starting the engine. Next, utilize the Honda Diagnostic System HDS to clear the DTC from the system. This process resets the error codes and provides a clean slate for diagnostics. Once cleared, start the engine and maintain a watchful eye on the system for at least 1 second. After that, check again for any pending or confirmed DTCs using the HDS. If DTC P0963 appears again, then the failure is confirmed and you should proceed to the next troubleshooting step. If it does not reappear, it may indicate an intermittent fault requiring further investigation into wiring and terminals. In the second step of diagnosing DTC P0963, the vehicle should first be turned off. Then, use the HDS to jump the SCS, Self-Diagnostic Connector line, to protect the Powertrain Control Module, PCM, from potential damage during testing. After securing the SCS jump, wait for more than 1 minute to allow the diagnostic system to stabilize. The next crucial move is to disconnect the connector PCM-C51P to gain access for resistance measurement. With the connector disconnected, measure the resistance between test points 1 and 2. You want to confirm that the resistance is between 5.0 to 6.3 ohms. If the readings fall within this range, it confirms that the CVT drive pulley pressure control solenoid valve is functioning correctly, leading you to check for other service information or PCM replacement if necessary. For the third troubleshooting step, begin by disconnecting the solenoid wire harness A8P connector. This action isolates the solenoid from the PCM circuitry. Next, power the vehicle to the on mode while keeping the solenoid connector disconnected. Use a multimeter to measure the voltage across test points 1 and 2. Test point 1 is the PCM connector C51P, number 4, and test point 2 is body ground. If a voltage is present, it indicates that there is a short to power in the DRLS wiring. The next step would be to repair any shorts identified between the solenoid wire harness A8P connector and the PCM. If no voltage is detected, then the DRLS wire is not shorted, necessitating a progression to the following diagnostic step. The fourth troubleshooting step requires you to turn the vehicle to the off lock mode, once again to ensure safety during the testing phase. You are tasked with checking for continuity in the DRLS line, which connects the solenoid and the PCM. Disconnect both the solenoid wire harness A8P connector and the PCM connector C51P to facilitate this test. Using a multimeter, you will measure continuity between test points 1 and 2. If continuity is present, this confirms that the DRLS wiring is intact and you can proceed to step 5. However, if continuity is lacking, this signals an open in the DRLS wiring that needs repair, which could be cutting off communication between the CVT solenoid and the vehicle's PCM. Rectifying this issue is crucial for the successful operation of the valve circuit. In this fifth step, you will again need to ensure the PCM is protected. So, repeat jumping the SCS line with HDS and allow for a necessary wait time of over 1 minute. After that, it is essential to disconnect PCM connector B51P from the system. This disconnection allows you to check the ground connections effectively. To perform the continuity test, use the multimeter between the designated test points, PCM connector B51P number 11, and body ground. And then, similarly, for test point 12. If continuity is identified, this signals there is a sound ground connection, and you can then advance to the next step. Conversely, if continuity is absent, there's likely an open issue in the ground wiring that needs rectification between PCM and body ground G101, which would be key to ensuring electrical stability in your system. Moving into the sixth step, you are required to disconnect the connector from the CVT drive pulley pressure control solenoid, valve 2P. This will allow for a more focused assessment of the valve itself. With the solenoid valve disconnected, it is time to measure the resistance between the designated test points in an off-vehicle condition. Here, you will check from terminal number 1 to terminal number 2 within the solenoid valve. If the resistance is reported between 5.0 to 6.3 ohms, this is indicative that the valve is operational and you can proceed to test the next aspect of the system. However, if the reading falls outside this range, it suggests the solenoid valve is faulty and requires replacement. This could prevent proper hydraulic function within the CVT. Thus, addressing this fault can help in restoring correct performance. At this stage, you need to conduct a continuity check on the DRC line, which is crucial for communication between the solenoid and ground. Make sure the vehicle is off and the CVT drive pulley pressure control solenoid valve 2P connector is disconnected to prevent circuit interference. Utilize the multimeter to verify if continuity exists between the designated test points. If continuity is observed, proceed to the next troubleshooting steps, as this means communication is intact. However, if there is no continuity, this indicates an open in the DRC wiring that requires urgent repair. Whether the break is in the line to body ground G161 or the ground connection itself is weak, it is vital to address these issues to ensure the solenoid has a proper ground and operates successfully within the vehicle's electrical system. The final troubleshooting step involves determining if there is an open wire in either the solenoid wire harness A or B. Start by disconnecting the solenoid wire harness B6P connector from the assembly. Ensure both solenoid wire harness A, 8P and B6P connectors, along with the CVT drive pulley pressure control solenoid valve 2P connector, are disconnected to facilitate proper continuity testing. As you measure between the specified test points, you want to identify any breaks in the connection. If continuity is present, repair the open in the DRC plus line between the solenoid wire harness A, 6P connector and the A, 8P connector. Should continuity be absent, however, it may indicate that the open is located between the CVT drive pulley, pressure control solenoid valve, and the solenoid wire harness B, 6P connector, necessitating an appropriate repair to restore circuit integrity. Once repairs have been executed, it is critical to perform a final verification to ensure all issues have been properly addressed. Begin by rechecking the error codes using the HDS to confirm that DTC P0963 has been resolved. After that, a test drive should be conducted under various driving conditions to evaluate the vehicle's performance and verify that the CVT operates smoothly without errors. If the vehicle responds well and accelerates normally, it indicates a successful repair. Additionally, ensure to double-check all connecting wires and terminals for secure attachment, as any loose connections can lead to reoccurrence of the DTC. Maintaining good communication with the CVT solenoid system is essential for optimal operation. Preventive maintenance is essential for reducing the likelihood of encountering DTC P0963 and ensures the longevity of the CVT system in your Honda CRV. Conduct regular inspections of the wiring harnesses, paying special attention to areas vulnerable to wear and tear, such as bends and joints. Ensure that all electrical connections to the CVT components are secure, as loose or corroded terminals can easily cause electrical faults leading to errors. Monitor the overall performance of the transmission. Any irregularities in shifting or acceleration should prompt an immediate inspection of the CVT system. By proactively addressing potential electrical issues, owners can significantly lessen the risk of future DTC occurrences, promoting sustained vehicle reliability and performance. In summary, DTC P0963 indicates a high voltage condition present in the CVT drive pulley pressure control valve circuit, emphasizing the importance of addressing this primary electrical issue. This condition arises mainly from wiring faults, whether shorts, opens, or poor ground connections. Given the complex nature of the CVT system in the Honda CRV from 2017 to 2022, a systematic approach to diagnosing and repairing any faults is imperative. Regular diagnostics and preventive measures can mitigate the reoccurrence of such issues significantly. Understanding the interdependent nature of each wiring component within the transmission aids not only in repairs, but enhances overall vehicle performance and safety. Please like and subscribe to the channel. See you next time.